Okay, I really hope that you find this note sheet helpful. It can be a little overwhelming at times. Realize, though, before we even attempt to start this, I'm probably going to record this in a few sessions just to make sure it records. But I just want you to know that we're going through a bunch of different exponential rules and scenarios that are important to remember as we apply them throughout the unit and our future math. So some of it might be quick and easy for you to remember. Some of it might be a little trickier and a little more unique. So that's the idea today, and we're going to expound upon that. So first of all, anything to the 0 power is 1. So we could write that out right now in words, but I want you just to, you're hearing the video right now. Remember, anytime we have anything raised to the 0 power, we get 1. So that's something that needs to come back to your memory here. When we have a negative exponent, we know that that's equivalent to 1 over same base but raised to the positive exponent p in this case. And another way to think about that, and again, it's just whichever scenario fits, is you can realize that that really is the same as the entire fraction 1 over a raised to the p power, because 1 to any power is just gonna be 1, so these are equivalent. All right. Likewise, when we look at something with a rational exponent like this, another way to think about that, just to visualize this, is to think of a to the p power and then times 1 over r. That's another way to think about it. That really says p times 1 over r, or p to the 1 over r. You can also think about that, write this up here, if you wanted to, again, depending on the situation. You could say a raised to the 1 over r power and then raise that to the p. Those are equivalent. All of 3 of these are equivalent, okay? But I'm going to follow this one right now because I want to talk about this concept of 1 over r. Well, that is exactly the same as the rth root, okay? A root with an index of r. So basically, that's r root a to the p power here. That is very important. We will see that a lot. So if we have a square root, it's really to the 1/2. If we have a cube root, it's really to the 1/3. Okay? And then another way to think about that could be that you're taking the r root of a and then raising that entire expression there to the p power. So again, just wanted to get a good note set here that you can go back to and you can remember, hopefully, a good foundation for the exponential rules and how they work. Okay, back to another basic one here, not needing to spend a lot of time on this one, but if you remember, we have like bases, exponents. When we're multiplying them together, the bases together, we add those exponents. I didn't say that the cleanest way, sorry. But that's the situation here. So multiply powers of like bases. Remember, when we do that, we add the exponents. Okay? All right, so likewise, a very straightforward example of that would be, algebraic example would be that this here would be x to the 4 plus 7 or 11th power. We really have 11 x's there if we were to expand it out, so that makes sense. And another straightforward evaluation here would be that this would be 5 to the 4 plus -1 or 1/3. So just a straightforward example of that would be getting 125 after we evaluate that. Okay, but now we're going to expound upon this and we're going to talk about expressions in different ways today. So I want you to think about this. This is already an exponential function. Hopefully you see that that is shifted left too. Well, what we're going to try to explore here is that you get you to realize using these exponential rules, that's identical to 4 to the x power times 4 squared. Let's think about that real quick. If we have like bases, isn't that the same as adding the exponents? So we're kind of going in the opposite direction. It's like starting with this and splitting it back, or going backwards to here. Okay? Well, then what is that equivalent to? Well, 4 squared is 16, so we actually have 16, and then we have times 4 to the x power. So if we were to actually put together in thoughts here, verbally, what is going on? Well, I want you to realize here that, an exponential
and I'm going to speak this out. I don't have a lot of space here for the words, but exponential base 4 shifted left 2 is equal to what? Well, if we do this, obviously it's equal to that. So if I was to go graph this left 2 exponential base of 4, then I would get something that's equivalent to, and then look at this one here at the end. Well, that's base 4 exponential, but it's got a vertical stretch factor of 16. So, you know, base 4 exponential vertical stretch factor of 16. Okay, I will post the notes, the keys to these notes tomorrow, so you can see these a little bit more clearly. It's kind of hard to write with this thing, but that's very important to realize. That's what we're going to ask you a bunch of is, hey, what is identical to what? Like, what is this the same as what function with transformations? Okay, I'm going to go ahead and I'm going to stop that here to keep these videos shorter so they're easier to upload.